Okay, everyone. Thank you very much for having me here. And what I will be talking about is a little bit of a theory, less practical because it has never really been implemented. We have never seen an institution of this type to reach this scale. We have seen things like social networks reaching the scale I'm talking about. So having almost everybody on earth being their customer, but we've never seen it in banking. And what I would like to discuss is actually if it is at all possible that we will one day see a Google, Amazon, Facebook, or Apple bank. A mythical one that actually everybody expects and nobody sees. Yeah? Let me start with the background of mine. So currently I'm a proud CTO of a business-to-business lending startup. We are still in silent mode, so you probably haven't heard about it. It will not be a technological breakthrough, but I hope the product will be a breakthrough. But it's not the subject of today, so I will just skip through it. I've been with banks of different sizes, mostly via the vendors of this banking software, and that's how I arrived at many of the conclusions I will be talking about today. I've seen this failing, and actually most of the examples I will be talking about, they are counterexamples, not really. So, of course, I will not name any customer. And one remark here. If you look at my history and find a bank, and I'm talking some negative things, probably it's not this bank, yeah, it's some other. So please remember that and don't use it as an argument when you go to any of those institutions to sell your, let's say, experience or product. Well, before joining the banking side, I've been with the military for quite a few years, and this is something I just cannot talk about and will not. And if I'm known for anything, I'm probably known for my participation in the open banking movement. I'm a reviewer of the standards. I'm an active participator of this area. And I've been also with one of the leading banks trying to implement it in some decent way and failed completely. Yeah. So the agenda of today will include discussion of this mythical GAFA bank. I will talk about the theory distributed systems. Yes, I know it's not a typical conference subject, but I want the physics to be back to our discussion so that we don't fly in the sky and clouds before we understand how it all is supposed to work. And surprisingly, physical systems are very good analogies, and I will be showing you why. Well, I would briefly talk about the tools, but rather from the context perspective and the mechanics, the paradigm, rather than the particular tool. I will not name a cloud solution for X or Y. And actually, in every cloud provider, you would find an example probably for the things you will need here, if we ever if we will ever try to do that. But actually, it's also available in different modes on-premise. If any of you have been on the presentation of Mr. Marek Lenz, he actually showed many, many reasons why cloud, well, probably for many banks will not be the answer. And actually, I do align to that in many ways. But what I will not talk about is banking in the wider context. And actually, banking is a wide subject. If we talk about investment banking, not something we are talking about here. If we talk about high-frequency trading, it's not something we talk about. So mainly retail banking, something that you need to basically pay for whatever, let's say from the internet platform, yeah? So a little bit of payments, your balance, your history. This is the core of the retail banking, but only a small portion of it. If we wanted to analyze it in the wider context, we would spend here much more than this presentation time. And I'm, of course, not talking much about the hype around the contemporary banking, AI, data science, the Bank 4.0, Brett King. Actually, I have a slide with Brett King there, but mostly to counter him. Okay, let's go forward. If anybody wants to ask me a question other than publicly, please share it with me. I will spend time to answer all asked. So Slido is a platform and there is a code, everything you need to ask the question. And it could be done anonymously if you choose so. So, setting up the scene. So can a retail bank holding an account for every person on earth, can it all exist? And can it be done such that the platform behind the scenes will be homogeneous? So if you look at the Polish part of this bank and the US part of this bank, it will run on the same architecture. That's the question I'm asking. And such a bank would be something that would be needed by an organization of a scale, let's say of a Facebook, if they really wanted to do universal banking. They probably will never try. That's another story. We'll maybe have a chance of talking about it. So look at the scale we are facing. I quoted, actually, those are official, let's say, releases from engineers of different social platforms. First from a little bit from Twitter, and then from Netflix. Those numbers are huge. Now, let's compare it with a typical bank. Typical, but really large one. Those numbers are taken, actually could be representative for the leading banks of several European markets. So it relies on physical data centers and they host several thousand servers. That's how many machines, let's say the first 3 of Polish banks run. Yeah, a few thousand, less than 10. Some more, some less, but this is the number. They handle load of around 1 to 2 transactions per second kilo. Yeah, so 1,000–2,000 transactions per second on the mutation side. That's the load they handle. From the query side, around order of magnitude more. Yeah, so 80–90% of the load comes from queries. And it is actually important, and I will talk about it a little bit. Most of them have one piece of magic logic that's called end-of-day process, also end-of-year, end-of-month. Cyclical processes that basically go through all their data and calculate all kinds of summaries. Yes, and they actually also tell you how much interest you earn or whatever else. It's quite typical, and this is so difficult to manage and to divide that if it grows above some threshold, the banks get in trouble because they cannot open the next day before they end that end-of-day process. And this does happen. And most of them actually run 2, 3, 5 environments at max, a typical progression of the development, testing, acceptance, and production, sometimes production mirror or shadow. So that's the level of complication they have. And let's go back. This is what they would need to face. And actually, I would ask you a question. Do you think it is more complicated to actually show the Twitter timeline or to show the banking account timeline? I don't know, honestly, but I would risk stating that the banking might be a little bit more difficult. So if we face the size, actually it will be worse than that. And this is scary. So, okay, let's go back. Let's start with that promise theory. Sorry. So please wear protective clothes. I will even show you some mathematics. So if somebody is not prepared, please leave the room. Yeah? Okay. For the purpose of this presentation, I have myself created a definition of what scalability is. It's actually nothing special here, but the most important thing I would like you to take a look at is that scalability cannot be taken outside of the context of metrics and performance. So basically, when we grow the system, we look at some parameters. And if those parameters stay where they should be. And it's so easy to look at this from a different and wrong perspective. If you take any metrics alone, it's easy to prove our system is scalable. For example, throughput. If we look at throughput, and we can say, we can easily sometimes prove, okay, with twice as many nodes, we can handle twice as many requests. But then, if we look at the latency aspect of it, it might be that it actually takes us for every single request 10 times longer. Is it still scalable? Or maybe we'll get an occasional odd one, yeah? A long tail. In banking, those are usually considered a no-go things, yeah? So this is something that we need to take a look at when we analyze if our systems scale. And to actually make informed decisions, we have several models. You've heard probably about all of those. And of course, all models are wrong. This is something that Mr. George Box said once, and actually he also said that they are still useful. And I'm today going to focus on one of them, and briefly maybe on another. You probably all heard about the CAP theorem or Brewer's theorem. So selecting two of the three, let's say, features, yeah, of a system is the best you can have. Yeah, you have either scalability in the sense that basically it's available, could be consistent, or could be partition tolerant. Not all of them. This is actually a super simplified version. And a more advanced one is called PACELC. PACELC theorem is something that I really encourage you to take a look at. And PACELC theorem adds one thing, latency. Latency is the physics of scalability. And actually, it is related to physics. It's related to the fact that information can be only transferred, let's say, with limited speed. Any informational channel that exists is bounded. And there is nothing you can do about it if you need to transfer one bit of information from here to the US. And this will always bound you. So this is something that I will show you how it limits scalability of systems in a moment. So there is a more universal law. It's called Universal Scalability Law because it's actually so general that all other could be derived from that. Not all other, all other that I've talked about. So our holy grail is this, linear scalability. Ability to have our system respond within the same parameters under, let's say, X times the load with X times the resources. This is not something you will see. Linear scalability in real systems is a myth. You just will sooner or later see contention and you will see the coherency problems. The contention problem is that the fact that basically not everything can be divided. What you see here is called Amdahl's law. Yeah? So if there is a percentage of the job to be done that can be divided and some that cannot be divided further, you can gain only as much. Simple, easy rule of thumb. But actually, it's not, again, the problem that we will need to face. Amdahl's law is not the reason we will not be able to scale banking systems. Banking systems will not scale because of the last element of this equation here, which is called sometimes the crosstalk penalty. The ability to agree state between different pieces of the system, to have it coherent. And the bankers all over the world, they do believe there cannot exist a banking system when the account balance is not coherent between the different parts of the system, which is actually not true. But all the bankers in the world will defend it. If you go to any of the banks and will try to convince them that you don't need it, you will be kicked out of the door. Yeah? So basically, that's the problem you will first need to face, is that before you scale, you'll need to convince them to change the model, and you can change the model. So one thing I want you to take a look at. I'm sorry. Oh, let me try to show you. I don't know if I will be able to. I'm not sure if that's not something I tried. Sorry. I will probably need some help with the presentation aspect of it. Wiesz, jak podzieli czekam, żeby wrócić z powrotem do tego? No dobra, duplikację zaraz zobaczymy. Oh yeah. Zobaczymy. Yes. Okay. The curve you see here. The curve you see here is exactly the curve drawn by this equation that I've shown you. And what it shows you is that pretty fast, in here around 6 times the original minimum size, so you might call it nodes or threads or whatever else is actually your scaling mechanism. It goes retrograde. What does it mean, retrograde? You add more and you get the negative return. And this is something that limits banking. This is something where basically if you need to replicate the core systems to handle more load, you will fail at some moment. You will fail as long as you believe that all those core systems will need to show you the same result at the same time from different sources of queries. And this really goes fast. I will tell you one thing. This is actually already very small, but I will make it a little bit smaller. Yeah. The efficiency of the system a little bit bigger. And we are still around 10 nodes where we see the retrograde. So if you think you can scale to hundreds of nodes for banking world, you will need a change of the approach. It will not. It will not. And that's why banks do succeed with their approaches they do have with vertical scaling. Yeah? So they basically invest a lot of time of very capable hardware that, at least from the outside perspective, looks like a single node. Actually, internally, it's not. So it's actually not really consistent in that way that we expect. There are caches inside. There are basically queues to writing your data to the disk, and all these things actually make it a distributed system. And understanding that it only, pretends to be consistent is another story. And actually, your point of start, if we really need to discuss it with any of the CIOs of a bank, yeah? So that they live in an illusion, and they do. Okay, let's try to go back to the PowerPoint. So, the Universal Scalability Law tells us how badly we are penalized for having the consistent state. And actually, this comes from the fact the number of relations between different nodes grows actually quadratic. Yeah, you've seen it. And that's why it's so bad. I will not spend all this presentation talking about it. So there is, for example, a source you can look at, and it's very practical. It shows you how to apply it. So please, if you need to, take a look at this. But how do banks really do scale? Like that. So they have a mainframe there, and if they need to scale, they buy a bigger mainframe. Then actually they pay several millions of dollars, or I don't know how much. Today I had a quote from Mr. Lenz, who said actually to migrate the core system, it would take 2 billion zlotys. I don't know, maybe. But okay, the machines themselves are a little bit cheaper, but anyway, those are tens of millions, easily. On top of that, the migration of their systems costs another 10 times as much, yeah, exactly. But they do scale like that forever. Forever means since the 80s. I'm sorry, I will skip one thing to show you this picture. So in the 80s, banking worked like that. when you had your salaries sent to the bank, you usually expected it on a day. Went there, wrote a check or whatever was the, let's say, document, and asked for the money out, and they sometimes told you that it's not yet there yet, yeah? So basically the queries and the transactions were in the same order of magnitude. And the banking systems has been designed for that. I mean it, the core systems, every single one that is out there has been designed as a transactional system that is heavily optimized for mutations. But the problem is, driver's change was supposed to be lost it. Well, anyway, yeah. The problem is that the queries currently grow much faster than transactions. The number of queries contemporary platform handle is at least an order of magnitude bigger than the number of transactions. And queries, of course, don't earn money. So to handle that, banks basically already started doing what I would suggest. They basically created satellite data stores optimized for queries. And it already happens. And those are not at all coherent to the master. So this already happens, and you would need to extend this model much further. And the observation I'm taking here actually is supported by some of the futurists, like Brett King, who is wrong in almost every aspect about banking. But the drivers change, yes, he is right. We want more interactive banking, and we get tools for that. With internet and mobile banking being probably the 10 point here. But now we get the social and the open banking, so open APIs and possibly banking from any other application that we possibly have, yeah, in our world. And then this guy predicts that we'll get interfaces that will enable us for more direct interaction, even human to device, yeah, human to machine interface, AR, VR, whatever, which might never happen. But if it does happen, it will, let's say, make the difference grow. So the difference between the query and transaction side. Because why transaction side doesn't grow that fast? It's pretty obvious, guys. It grows as fast as we do grow the number of things we buy. Yeah? And this, if you bought your iPhone, you will not buy another because of the availability of another banking channel. You don't buy one on the mobile and then another in the internet banking. Or via 3 of your existing mobiles. Yeah? So this will not change that much. But with your 3 existing mobiles, you will have an application running of each of them, and that will query the bank every 5 seconds to see if your balance changed, which of course didn't change at all, because your salary only appears once in a month. So you need to address that. Okay. So can the scalability model of banks be changed? So guys, what happens if we have incoherent state in a platform like Netflix? Okay, you maybe see wrong recommendation, like the one I have here, yeah, which basically showed some, I don't know, 2 days ago, my cousins did watch some kids' movies, and now I've been, let's say, presented with this as a recommendation because the device didn't synchronize the state. Okay, I can live with that. I will just seek what I need to. Well. You probably have seen this once. This is actually a LinkedIn feed. And this is a very good example because actually it started to expose this once Microsoft took over. So basically you sometimes see time travel. So 1,000 or 5,000 people have seen your post. And 5 minutes later, actually 100 less seen your post. How is it possible? So it is exactly the case that they have multiple copies of the data, and they didn't care that much to synchronize them. And they thought it's acceptable. Yeah? And actually it is. We probably don't care about the small numbers at the end that much. But actually, as long as it wasn't Microsoft, I've never observed it. So they did change the approach. They did change the approach, and they did it for a reason. They observed something that allowed them to optimize by allowing this anomaly. But if this anomaly happens to you, well, you've just got your salary. You go to the ATM and you are refused. This is the exact same thing. No difference at all. But you will be quite unhappy with your bank. So the banks don't really want it. The anomaly I'm talking about in the system story is called the read monotonicity anomaly. Yeah? So basically the fact that you can read something that is already in the past. You have been shown a later state, and this later state now is like erased, and you are again shown an old one. So my claim here is that banks don't need ACID-style consistency. Most of the time, they need only monotonicity. And for monotonicity, you have other tools than consistency. Consistency allows you to have the monotonic reads, yes. But it's the ultimate weapon, and it will prevent you from scale. So what else do you have? Well, actually pretty simple things that we've done forever. Who knows about sticky sessions? Yeah? So sticky sessions was actually that. You had a cache with every node called session, and this cache, if you hit a random node, you would see different results. So you don't want it. So you make sure you hit the same node. And this is so easy, and it's been done. Twitter, exactly, this is how they designed their early systems. They had several thousand of, I think, Redis instances. And each of them had a portion of their customer base history. The only thing they've made sure is that when you hit their systems, you are consistently routed to the one that has your data. And the banks can do the same. They can do the same, they just don't do that. Yeah? Not yet. Okay. That was another illustration of the bad things that could happen. Let's skip it. So my claim here, it's the only place that banks really need ACID-style consistency is the payment authorization. If when you decide whether you can pay out $100, because if you don't have those dollars, you shouldn't be allowed to. And you need to be sure, or at least banks, again, think that you need to be sure. There are already banks in the world that took the risk-based approach. So they really don't care that much that if you do have the money. At least they have some percentage of, let's say, they are convinced in some percentage that they do have the money, but they take some risk. I don't know, 1% risk that you are out of balance. Okay, let's try. But then you will probably go for $1 million transfer, and then they will make sure that it is really strictly consistent. Yeah, but normally, they don't care that much. And this claim allows us to really change the approach. Yeah? So we talked about the physics. We talked about the mechanics, the theory. And let's see what, okay. This was something that I wanted to return here. The banks were scalable in the 80s when the branch model was the prevalent one. If you had to serve more customers, you opened more branches because they only dealt with their single point of contact called branch. They went to the clerk and asked for their money. And it was only important that the clerk in this particular branch knew how much money you do have. They never synchronized it, except for aggregate, so basically so that the reports to the CEO of the bank was roughly correct about the numbers so they could know how much they could spend on their new Ferrari. Yeah, so this is what they did. And okay, the regulatory frameworks are now much more demanding. You need to have quicker reports. But overall, if we could achieve that, so if we could shard the bank system, we could achieve the scalability we need. But we probably will not be able to. And okay, so that was the locality here. Okay, but there are more aspects to that. Security is a problem that we will face, and why? Because all banks in the world I know, all that I've worked with, do this thing, perimeter. They defend the perimeter of the bank. They fence it high with the firewalls and whatever else. They create their, let's say, delimitarized zones. It's all about perimeter. What comes through the perimeter, hardly any bank in the world really has anything than possibly some anomaly detection. They really don't defend there. Now, this is actually the picture from 4 days ago by Monzo Bank. They showed that how did they isolate their microservices, and they have beautifully visualized the 1,500 microservices and the links between them. With each of the lines is the allowed connection. No, any other connection that is not on the whitelist will not succeed. That's what they said. But why do you have the perimeter here? How do you draw one? This is not possible. And actually, their approach shows that this is something that they have foreseen, and basically they think that they will need it to change the approach. And they were originally defending the perimeter. That was their original approach. So we have some signs, but this is from the newcomer of the banking world, a small bank in UK that have hardly, I don't know, 3 million customers. Will they be able to manage it at scale? Nobody knows. I don't know, and probably not them. But they think that they will be. What they use here, they actually use network policies on Kubernetes and to do that, yeah? So tools are there. The question is, can those be managed if this grew another 10 times? I don't know. But one thing that they observed here, this is a classic model, yeah, of the security enforcement, which basically there is a point that you enforce any policy, and then there is a separate point that you decide about allowing or disallowing any communication or action. And then, of course, you have managing mechanics of it. For a bank to scale infinitely, this would also need to scale infinitely. And actually, I am not that much concerned about the policy enforcement point, because I will show you how this could be scaled with the systems. Possibly not the policy decision point, but management? Oh, this is going to hurt. So I'm not sure if it is at all doable. The path to scale, I already showed you why anything shared, I mean anything. Is it network? Is it the database and the data inside? Is it the management interface? Will prevent you from scale infinitely. You will have the congestion at some moment. We don't know which exact one, but probably well below the scale that we started with here. So the path to scale is actually to get rid of the shared state. But even the best sources out there, this is from the 12-factor, you might say, manifesto. And those guys are people who drew the model that we think is the way to develop contemporary applications, do have misconceptions, or say they at least embed their ideas of how far they will only go to scale. For example, in here, they say that, well, 12-factor processors are stateless and shared nothing. And then to achieve it, they say, well, there is a database behind. Well, this doesn't share. It's not a shared nothing, it's shared database. Yes, even if it is between instances of the same service. But if you need to have 1 million instances of this, you will be hit. Or I talked about the sticky sessions. Well, they think it's a very, very bad idea. But actually, affinity is something you will need. So Those recipes are simplifications. And please remember that. Before you rule out a solution like that because of a rule from the well-established authors, you should actually consider what was the context they wrote it in. Yeah? So if you blindly copy it, you will see a lot of misconceptions. I talked about how banks try to scale, and they do actually do this. Currently, they move away from the ETL processes, and the data warehouses are being fed in a more eventful style. And actually, their ODSs sometimes become embedded in their applications. So everything satellite, except the core system, becomes more and more scalable. And this is happening. This is happening. If you go to, I don't know, PKOBP, you will probably see a program here about copying every single piece of data in the core system to Cassandra for the purpose of having it queried cheaply, yeah, let's say. So they do it. How far they can go with that, I don't know, but of course, we all expect that we will see CQRS-like systems and even sourcing. I don't know if they will really reach it, but the newcomers to the space do try. They just never reach the scale that we can really judge if they are successful. There's still 1-2 million customers, which is nothing. They could support it with the single relational database, so they have proven nothing yet. Yeah. I borrowed this picture from Michał Żądło because he actually could draw it and I couldn't. So one thing I wanted to point you that you will see shared resources in unexpected places. In here, the event bus is something you can trip on. Really. How many partitions the largest Kafka cluster can run? Do anybody has an idea? Okay, much less than 10,000. Yeah? And with each of those partitions being able to maybe support 2,000-3,000 TPS or messages per second. Where does it take you? Not a few millions per second, yeah? From a single cluster, you'll never go further than that because of the shared resources of this cluster, coordination between the partition. It's hidden. They all claim it's beautifully scalable linearly. It's not until it breaks. Yeah, it only goes that far. So there are unexpected places that you will hit your, let's say, limits. And when I showed you the original slide talking about Twitter, they actually do run message brokers, yes, and actually they do run Kafka-like systems. But they said they have hundreds of those. What does it mean? They have another framework on top of it. So they have a meta system on top of it. And of course, hierarchical systems like that will serve you until some point, but at some moment, those hierarchy will become too big. And again, I don't know the answer, if it is below or above the threshold of, let's say, having an account for every single person on Earth. Nobody tested. And the test is your ultimate answer, nothing else. So, well, all these smart answers are only counterexamples. I cannot give you the positive one. Okay, so I talked about the tendency of the banks to share things in the middle, the mediator pattern. And mediator pattern is everywhere. We would like to do this. And what I have just illustrated is a contemporary mesh architecture. Mesh architectures probably are the future because they scale well with the system itself. You have a piece living together with every single application you run, a single instance of the service. This can be actually done like that. Sidecar pattern. Yes? So we do have already some answers. We just haven't tested yet at this scale. But it runs pretty well for the social platforms, so we can risk the statement that it will work for the banks too. one thing that I wanted you to point to at, banks are still here, 2005, ESBs. And today, it's today that the CIO of a large bank was talking about the red day called 10th of the month when the salaries are paid in Poland. On the red day, in every single bank of the top 5 in Poland, you cannot run a marketing campaign because you will saturate your ESB. Yeah? No, on the yellow day, actually, you are limited to reach at most 100,000 customers. Those kind of rules do exist in the bank, so they have already hit their limits. And the problem is that, I would say, still the pain is not big enough to make them convert. We'll see if it will happen, but I do think it's not one of the high street banks that will try it. Okay, I was talking about service meshes and applications actually having embedded pieces, and this path is something that is commonly seen. If you look at Netflix and libraries like Hystrix, they decided against service meshes because they thought, well, honestly, you cannot really abstract it to the level we need, so we will still need a piece living with the application that has some common logic, but not common enough. So they basically said, well, let's rather put it with the application itself and scale it this way. One final aspect, I think, because I have like 2 or 3 minutes left, I don't know. So I will not bore you to death. Guys, banks are currently not able to deliver a change. The cycle in a typical bank is months. They have those max 5 environments that they need to share with tens of vendors, and this prevents them from actually doing much. Because most of the time, your environment is locked by somebody else. And I really experienced that. So before we get rid of any other issues, we need to get rid of the delivery pipeline issues. And this is something that cloud can help. And actually, this is already seen by banks, that banks do think that R&D and tests environments is something that they will migrate first. And this is actually not the bad solution, because this takes away one of the main pain points, really. Okay, so will it ever be implemented in a summary? I think it will not. Not because of the technical issues and that it's impossible. It's just economically not viable. The differences between the countries and the regions and the people around the world are difficult enough to abstract that it just doesn't make sense. So even if there will be a bank that will have a single brand, let's say the Google or Facebook bank, around the world, it will be heterogeneous. It will run different stacks, it will different systems, and actually you will have a different mix of services in different regions. That's my take to the subject. So probably we'll never test my theories here. Thank you very much. And, well, thank you for having me here.